again, top left corner here if you click on it, but the striations aren't always, and you'll kind of find this in the slides, you know what you're supposed to see, but sometimes we can't always see, great striations in a slide, but maybe some other features such as this elongation and cells. Where are we going as far as if we say yes or no to that? Is muscular tissue. So here I pulled up another image with 3 types of muscle tissue again, and I think the striations and intercalated discs are a little less pronounced in this, so it's good to, as distinguishing muscle, be aware of kind of the shape or the location of the nuclei as well. So that's the next feature we'll focus on. And if anyone knows off the top, what are some of the features we're looking for here as far as the nuclei to help us distinguish? All right, so then, that's a good question. Cardiac has more striations. More is hard to say, but there is a specific type of. So what is a striation? So where it is located in the cell, and then stepping back, what is that? Again, if we were to say doesn't know by now, hopefully yes, no, but we'll create a new page here. A striation is a perpendicular line. So if the muscle cell in a particular side we look at, and this isn't always the case, but if it's kind of running parallel or horizontally, we'll see these perpendicular kind of filament lines somewhat close together. Our options here are central, up and down to the muscle. And then, so yeah, we're kind of now dealing with, someone has, this cardiac have more definition there, but just peripheral, it's probably, again, we want to perhaps be a little more specific, but there's a specific type of, line or which of those are centrally located and which are peripherally located to that, and not skeletal muscle. Anyone know what that is called? Okay, good. So we have intercalated discs. Great. Okay, centrally located. Now let's pull up that picture that we just had here to, I'll put it in the box again. Skeletal being peripheral, and how about cardiac? Okay, central as well. Great. And then when on these features about, say, A is number of skeletal as well, whatever, kind of referring back to that picture, which one, based on these features, that we could categorize. Again, in some of these, it's kind of hard to distinguish which is the cell, but as a general feature, we'll say some are multinucleated, some might be binucleated versus single nucleated. So how would we assign that to each category? All right, so yeah, B is cardiac because of the disc. Good. Okay, so cardiac is smooth. No, smooth, okay. Now, there always tends to be some exceptions. Good, so we have that correct here. We have smooth cardiac. Smooth is always skeletal, kind of as the framework. Mononucleated. And this is one where we can kind of see the cardiac being binucleated. But again, that's where we use other kind of features to distinguish things. So you might see disc in between the cardiac, but skeletal is the one there. Good question. Really multinucleated. Again, if we pull up that last picture, intercalated disc. Some people will describe cardiac muscle as somewhat peripherally located on the cell, branched. And so, so this is kind of, I think, a good kind of creating very just real quick to actually pull up type of separations between the cardiac muscle cells here, and they serve the purpose kind of for helping cell-cell communication to transfer the signal of, it wouldn't add anything new. But anyway, the point is contraction of the muscle cells. Which tissue is which from the most recent picture? Is that okay? So it's basically just a connection between adjacent cells. Okay, so it's good to kind of focus on the striation thing.